So our next speaker is Bruce Large. Bruce, do you want to go ahead and turn your camera and make sure everything's good? And then, Bruce is someone that I know from actually SANS ICS 515, where Bruce was in a class of mine down in Australia. It was one of my all-time favorite classes of just fantastic folks from all around the industry and on multiple different industries, mining, electric, water, etc. It was just such a good time. And Bruce at the time was at an asset owner, an operator, so he was at an electric company and working the problems on that side of the space. And now he's an OT security lead over at CyberCX. So it's just been really exciting. I know Bruce has had a lot of involvement in the community, anyways, and doing all that. But just from my small period of getting to know Bruce and watching his growth in our community in that short amount of time, it's just been really awesome to watch. I've seen him all the time going out to like local events, and there'll be a LinkedIn thing that pops up every now and then with him going out and talking about ICS security to other groups. And it's just really always cool to see kind of these. They're not evangelists, they're practitioners, but there's almost an evangelical, like, let's get out and tell other people about this wonderful ICS security world. So Bruce, I really appreciate what you've been doing. Appreciate having had the opportunity to meet you and interact with you. Really looking forward to this talk as well, as it's something I'm really excited about, and talk a lot about the need for defensible architectures, and to have your perspective as a practitioner out in the field, sharing it with our group. It's just awesome. So thank you, and over to you, sir.
Yeah, thanks, Rob. Just checking you guys can hear me.
Sure can.
Awesome.
There's a filter though, and I think it makes you sound like you're a Kiwi. No, I'm joking.
It's just the Anzac tradition, Rob. But no, thank you for having me, and it's pretty exciting. So, yeah, I'm a huge nerd for this stuff, so it's really awesome. But yeah, so today we're going to talk about security architecture. So, agenda for today, what is security architecture? Planning security architecture, establishing security architecture. I think importantly, how to upkeep security architecture, and then some homework and next steps. So who am I? I'm Bruce Large. You can find me on Twitter at blarge. And this is a pretty cool photo of me in front of the original generation control room at one of our power stations in Queensland. I'm the operational technology security lead at CyberCX, and I'm a cybersecurity specialist who's worked across IT and OT and security and network engineering roles for 15 years. Oh, sorry. I'm an infrastructure tourist. Thank you to Practical Engineering for that term, and a cybersecurity architecture enthusiast. I have experience in rail, electricity generation, aviation, emergency services, and consulting. And I'm also the Vice Chair of the Queensland branch of the Information, Telecommunications and Electronics Engineering College of Engineers Australia. And I have a Bachelor of Engineering in Telecoms and a Master of Business in Applied Finance. Like Rob said, I had the privilege of doing 515, so I got a grid. I'm a SANS Chartered Foundation and CCNP lapsed. So what is architecture? So from the sliding scale of cybersecurity, it is the first step. So as Rob says, architecture refers to the planning, establishing and upkeep of systems with security in mind. And ensuring that security is designed into the system provides a foundation upon which all aspects of security can build. And it's important that in that triangle that, it's the lowest cost and the best bang for buck. And I'm a huge fan of the C2M2. I've actually been pinging Jason, which has been fantastic. And from the draft V2 C2M2, these definitions are quite useful. So cybersecurity architecture, so thinking about practices and controls, thinking about CIA for assets and services, and enterprise architecture, so design, description of the entire set of IT and OT, how it's configured, how it's integrated. And network architecture, which is something I'm very familiar with, the framework and structure for comms among IT and OT assets, and to describe rules and interactions and interconnection. So the C2M2 is built with domains, and within domains, there's objectives and then practices. So in V2, there's actually an entire domain for architecture. So the first is establishing and maintaining a strategy and program. There's a segmentation strategy. There is AppSec as an element of the architecture, and there's also data security as an element of the architecture. And for C2M2, there's management activities. And I don't want to read out everything, but in C2M2, we have this concept of MILs, maturity indicator levels, going from MIL 1, 2, and 3. But if you're starting to build out your cybersecurity program, this is an excellent point for building out your architecture components. So yeah, from how we establish and maintain to how we implement segmentation, how we do AppSec, and how we do data security. So I kind of just want to touch on the differences of ESA and security solution architecture. So in ESA, we're thinking, we're working with the business to define security strategy and justification. And we're also defining an enterprise-wide security approach. And we're doing things like principles. We're looking at, for SABSA shop, attributes modeling, domain modeling, trust models, and looking after our pattern repositories. And we also run our architectural review board. And contrasting that with security solution architecture, which is more about, it's a key pivot role between whole of enterprise and delivering projects. It focuses on producing solution designs that address the cybersecurity requirements as per the enterprise methodology, and more than likely going to be part of the projects team. And I'm a huge fan of the NIST-NICE, the National Initiative for Cybersecurity Education. And I'd highly recommend, if you haven't seen it, have a look and check out SP ARCO 1 and ARCO 2 to kind of look at the differences of knowledge, skills, and abilities for both roles. And just one other thing before I jump off, just really want to focus, I often see a gap between these two worlds. That's why there's a gap in the slide, but it's really important that both sides work with each other and understand each other's viewpoints. And also it's really important that both of us understand, what's happening in the process, what's happening in the field, and just having that, I guess, empathy for the people that have to use these systems. So yeah, building off the kind of the structure from the sliding scale, let's talk about planning activities. So how we understand our business, understand our systems, and understand our requirements. So I'm a massive fanboy of SABSA, the Sherwood Applied Business Security Architecture. I actually have a signed copy of the Blue Book from David Linus, but it's a framework that can provide business justification for cybersecurity efforts. And there's probably three main parts, right? There's the matrix, two-way traceability, and things like domain modeling that are really, really important. So when I did my training with David, one of the most, I'm going to walk through one of the slides that I found most useful. So SABSA has its roots in building security architecture for the SWIFT payments network. And from that, they used ISO 7498, which is the security standards for the OSI model. So starting with logical services and physical mechanisms, they then built out the contextual and conceptual layers of architecture to support that. And also then a component layer to kind of address the control configuration. And importantly in cybersecurity, as we all know, it's not fire and forget, it's how do you manage it in production. They then apply the journalistic who, what, when, where, why, or in SABSA's case, assets, motivation, process, people, location, and time. Then from that, we can start building a 36-cell matrix, and I won't read it all out, but this first layer is what we call the business view. So talking about what the business kind of aspects are. We then build out our conceptual layer, which we call the architect's view, the logical layer, which is the designer's view, the physical layer, which is the builder's view, the component layer, which is the tradesman view, probably should be tradespersons these days, and service management, which is the service manager's view. So I would highly recommend check out the link below, the SABSA white paper, excellent resource. But through this matrix, we can start building all the information we need to build a whole of enterprise approach to security architecture. So two-way traceability is super important, right? So when we go top down, we're looking at completeness. So, making sure we don't forget things, and going bottom up, business justification, which is one of the most critical functions. When the business comes to us and says, why do I need that firewall? Or why do I need, some kind of cloud security solution? We should be able to trace that all the way up to achieving some business objective. And, awesome comments before from Jason of how do we speak in the language of the people that we need to kind of, get on board with risk and whatnot. And then I think one of the most critical things is actually domain modeling. So SABSA defines a domain as a set of elements that are subject to a common security policy defined and owned by a single security policy authority. This is really important. So for a logical domain, it could be something like a line of business, classification, maybe an information sensitivity rating, or a community of users. And for a physical domain, it's a set of physical elements that could be in the same physical location or technology layer that are subject to a common security policy. And this is referenced from the SABSA F1 and F2 course materials. So something else that I think is vitally important as architects is that we think in capabilities. So rather than thinking about a firewall or a host-based EDR or whatever it is, we need to think at a higher level so we can kind of build out that structure for people to use later. And it's through these capabilities, it's a bridge between a conceptual enterprise security architecture and the security solution architecture. So to begin with, if we're thinking in the ESA space, again, I quite like the C2M2, looking at domains and then objectives, so program management or situational awareness. Then moving into something like 62443, which I'm a huge fan of as well. Probably picked by now, I'm a fan of many things. But in that, we're talking about logical component layers, thinking about foundational requirements, and down fully into a component layer with NIST 800A2, where we're mapping controls with an ICS perspective. So we've kind of done our homework. We're thinking about what we're doing. We're now into establishing activities. So how do we build cybersecurity throughout the life cycle of the system? So, yep, I really love NAP's 3x3 model. So this is in Knapp and Samini's Applied Cybersecurity in the Smart Grid book. What I like about it is it thinks about both the location and the component layer. And it's a very simple visual model, and we can use it to communicate control placement and to identify if we've got any blind spots. And if you haven't seen, the link is below for a blog article that explains, but to me, fantastic resource to be able to get everyone on the same page. Zones and conduits. So I actually remember like years ago, I kind of knew this, but I didn't know what to call it. So a zone is, a grouping of logical physical assets, could be based on criteria such as, the type of asset, function, location, whatnot. And then conduits are really important because they're the communication channels that allow us to enforce cybersecurity policy when connecting to two or more zones. Then moving into NIST 800A2 for specific control advice. It's a fantastic book. I've actually got a printed copy behind me, bound. But really good background context, overview of ICS, risk management, programs, network architecture. And I find with a lot of these things, the appendices are where the real gold is, right? So things like threat sources, vulnerabilities, current activities, and how to apply 853. So yeah, I love it because it's got security controls with ICS specific recommendations and guidance. And it also has a library of threats and vulnerabilities. And controls for 62443 are super important, right? So we have our foundational requirements from FR1 to 7. And then, we have our system requirements and requirement enhancements. So as a network guy, I love FR5, restricted data flow. So our foundational requirement, we then have our system requirements and our requirement enhancements. Really important too that we have security levels. So depending on the risk of that system under consideration, what level of security is enough, which is always the really difficult challenge in this space. If you look through the standard, you get some background, some rationale, some supplemental guidance, and then you also get more specific control guidance for requirement enhancements. So I pulled this just from 6244333. Massive fan of the Dragos collection management framework. So I feel we've spent way too much effort on identification and protection activities. And unfortunately, we've underlooked detection. And I think the quote, prevention is ideal, but detection is a must, is absolutely critical. So if you haven't seen it, definitely grab the collection management framework. It's a cyclical process. Start with our requirements, could be from a tabletop, crown jewels, threat modeling. Build our collection management plan, go build it, test it, see how it works, feed that back in, right? Have a continuous improvement cycle. And, big fan of examples. This is one of the tables. We consider where the asset is. We consider the asset type. We consider the logging information. And I think critically, where it's stored and how long we have it. And this is a really, really useful thing to know when you're doing threat hunting or, you're thinking about a tabletop activity. Can we actually do this? Really excellent tool to use. I'm actually stoked. I've been talking to Sarah and pinging back and forward, and Peter Jackson actually called out, like, in this actual summit, we're going to be talking about the next gen of procurement advice, but these documents are fantastic, ready to go, ready to pick up, good mix of material. And supply chain is the biggest wicked problem we have, right? And it's across the entire ecosystem, and it's something that we really need to think about through the whole life cycle. So if you haven't seen the first one from 2009, gives some nice background, some language guidance. I love the fact that it has procurement language that you can pick and shift. And then awesome that it considers FAT, SAT, and in operations and references. Just absolute gold resource. And then if you're in energy, which is one of my backgrounds, there's a specific one for energy delivery systems, which is a bit tailored and a bit condensed, but another fantastic resource that you should use when you're trying to think, how do I manage supply chain from an architectural viewpoint? So case study. So this is the most exciting part. So when I was talking to Rob, he's like, hey, let's talk about what you do. So first off, these aren't any real networks. This is just my general knowledge and a bit of internet and just, ideas I have. So don't think it's a particular company. So huge fan of railways, cut my teeth in the railways in Australia and Queensland. And railways operate many industrial control systems and asset protection systems. So things like signaling systems, safety critical power supervisory systems, asset protection systems, which are super cool. They're like infrared cameras and like impact detectors and dragging equipment detectors and lasers that check to see if things are over height. Basically all the super cool stuff that then gets put onto the network. And my background, voice and radio telecom systems, which are mission critical in railways and safety critical. Some requirements, like you probably want to build a network that can carry both IT and OT. And if you're doing that, you have to segregate and segment. A system that needs to be flexible to be carried across many transmission types, private fiber, microwave, carrier, even satellite systems. It should be highly available and cost effective. So if you think about domain models, really important to start here, right? So it's helping us understand our policy domains and our policy authorities, and critically to think about when domains interact with domains, who's driving the policy, who's the ultimate policy authority. Because if we're not getting it right at that level, it's really hard to then do the technical, right? So in this case, we've got IT, we've got OT. Once we get into ops, op tele, signaling, electrical, asset protection. Then thinking logical, I think this is where 62443 and zones and conduits comes in really handy. So level 5 and 4, we have our corporate internet gateway, internal data center networks, our operational business systems. Level 3, think of this as the control center. Level 2 and 1, this is equipment out by track. When you're on a train, you see those little white huts. That's where all the, kind of electronics are. And level 0 is stuff on the track. It could be mechanical things, points, the actual overhead electrical systems. So it's interesting to think about what are the interactions between these different zones, because often it's at the point of interaction that we insert security controls. So we think about what are the conduits as we move between layers, or even as we move in the same layer. So then this is where it gets cool. So let's think about what the builder's view could look like. So like I said, we have a control system. We might have a few systems here. Some might have firewalls, some don't have firewalls. We then have our kind of like WAN backbone, which is an MPLS cloud, so multi-protocol label switching cloud, which is the IP technology that carriers use to build, carrier IP networks. And then we might have different site types. So some might be high-risk sites where we have firewalls. Others are just, just a router and local switching. So we think about where do we put security here, right? So network segmentation, my favorite control. So where we have a firewall, we can do network segmentation. AAA, so authentication, accounting, and authorization services, really important. How do we know how to authenticate people and know what they're doing? And logging. And in here, you can see I've chosen some places we have logging. Maybe we don't have logging everywhere. So this is a great time to flick over to NAPS 3x3, right? So if we think where we are on the 3x3, in the network, we have network seg at the control center. We have some network seg at device networks. If we think about endpoints, yeah, we got some stuff in the SCADA layer, not a lot going on in the device networks. And for data controls, we don't have a lot. So maybe we need to have another look at this. So industrial network intrusion detection systems, many vendors, some on the call right now, fantastic capability, right? And a capability that's definitely emerging. I think back to, doing this like 10 years ago, I remember actually talking to someone who said, oh, there's this thing called, like Snort, or, there's a thing called Security Onion, you should go play with it. So very exciting time to be in. And the other thing is device configuration baselining is really critical, right? So if we can at least know that something has changed, we can then start looking to see, is this a sanction change? Is this an unauthorized change? And the way we can do this can be non-intrusive to the actual system through things like network telemetry. So if we go back to NAPS 3x3, hey, this is looking better now, right? We've got some coverage. So if we think about data, we've got our baseline configuration picking things up. And we can be using our industrial NIDs to be assisting with this too, right? And maybe we do some more network segmentation. So to me, this is why I like NAPS 3x3, because it's a nice tool to kind of pull everyone together. So my background's been mostly SCADA, and just recently I've been exposed to DCS, and it's a totally different world. So thinking about electricity generation, coal-fired power stations are incredibly large, complicated, and interconnected processes. I think from memory, the power stations I have worked at have had up to 1,000 PID loops, which is pretty impressive. And there's a bunch of different subsystems, right? So air and fuel, so how we grind the coal up and put it into the boiler. The steam cycle, so how we've got from the boiler into the drum, into the actual turbines, out of the turbines into reheaters, back into other turbines, and then back into a condenser. The electrical generation equipment, which is why we're here. I was shocked at just water chemistry as a comms engineer. I was like, wow, I did not expect this. It's really important that you get water chemistry right in a power station. If you get it wrong, within a couple of weeks, you can actually, physically destroy the plant. And then balance of plant. So a power station is actually a really large user of industrial systems, right? So things like massive fans, massive grinders, just lots of bulk energy. So it actually takes a bit of energy to create energy. So if we think about requirements, we need to work within our DCS vendors approved standards. If we don't, we can risk support issues. It should be an integrated control and monitoring system. It's probably within a small contained geographic region. So LAN networking and security is really, really important. Availability is especially critical for energy. And you need to consider a secure remote access vendor, secure remote access for your DCS vendor, which has been highlighted just recently with Ultmar and other examples. And with the changing of the grid, it's vitally important that we can get process data to the business to enable real-time business decisions. With the the growth of renewable energy, this system is being rapidly transformed, and yeah, it's just super important we can get real-time information back to the business. So back to domain models, and I just wanted to take a second here to kind of contrast the difference. You might have a different structure of policy authorities. Each power station could be its own policy authority. There could be a central group, and the power stations actually could be structured differently to your central group. And this is really important when we think about who's setting policy, who's setting exceptions, who's setting policy between subdomains. So just something to be very mindful of, because this will help you in your stakeholder engagement. If we think about the builder's view, so back to Purdue, so level 4, let's assume all the nice internet stuff's offsite, and we drop into 3.5 OTDMZ down through the levels. So if we think about control placement again, my boy, network segmentation comes up. We might have multi-factor authentication, right? When we're coming from lower trust zones into higher trust zones, we really, really want to make sure they're the right people doing stuff. Logging again through the environment. AAA, again, super important. But this is where supply chain might be coming in, right? So our vendor contracts, like what do we have in our contracts to enforce that vendors have to do things? They have to let us know about stuff. If key people leave, we have to roll passwords. How do we actually have a contract to give us comfort that is happening? So again, industrial NIDs, really important here, right? Start on the edge, build your way through the network. I think the majority of the risk starts on the edge, and as we move into the network, we can get better visibility. And again, device configuration baselining, super important. Did something change? Why did it change? Who changed it? Really, really critical for when we're doing incident response. So I thought I'd then kind of touch on what maybe the component level could look like. So security pattern, again, remote access. We have our third-party vendor. We can talk about controls placement and what types of controls we should have. And this is then really useful because this becomes a generic high-level design that we can roll across the entire environment. And if we do that, hopefully in future, if we find a security issue, there's a lot of consistency, which means we can quickly fix things. But it's not always the case. But yeah, to me, this is what I'd like to see in a security pattern. And we'll touch on this in a little bit, but I think this is where we need to get to. And then in the future, we can get into things like formally modeling in Archimate, but there's only so much I can do in half an hour. So we're on the home stretch, upkeep of architecture. How do we sustain this? So it has to be a living process, right? Architecture cannot be fire and forget. You have to get management support and buy-in, and it's up to us as architects to be able to articulate architecture as a whole of life cycle capability and to use the language of the business. We can't just talk to them in technical. Again, Jason's slides around, we can't talk about firewall hits to the CEO, right? It's just not gonna work. They don't get it. That's where two-way traceability really, really helps. And then we have to embed architectural thinking in all the processes we already have, be they business, technology, or projects processes. It's really hard if there's no alignment and different teams are not working with each other. So I'm a huge fan of patterns, and I'm a huge fan of opensecurityarchitecture.org. Now, patterns are, to me, an excellent tool because they help us share knowledge, sustain standards. It helps us simplify our operational cybersecurity risk by having, consistency in the environment. And I don't know if you guys have sat on an architecture review board, but it makes it a lot easier. Huge fan of Open Security Architecture SP023, which is how to do cybersecurity for an industrial control system. Looks a bit like, data flow diagram. We have our kind of trust boundaries, our actors, our key assets, and we have controls placement, right? And to me, this is a reference design that we can use through the organization. And if we have a standard pattern library, it's much easier to do version control than trying to remember which site was good. I can't remember. I've had experience where, we might have 200 sites and we just copy configuration. It's really hard to remember which is the good one. And it's especially hard when you have different people building out systems to know which is the gold standard. And you can imagine if we have an incident, how do we figure out what we need to do and what we need to fix? So next steps, and I'm a big fan of Rob for this. I saw this on his RSAC preso, I think last year, but I've thrown a lot of content at you. What are the tangible next steps? So let's think next week, next month, next 6 months. So in the next week, have a look at the presentation again, and just think in your organization, think about your capability in planning, establishing, and upkeep. And just reach out to your tech teams, share the material, have a chat to them, see what they think. In the next month, you should definitely have a central point to keep your architectural material if you don't already. Also, bonus tip, you probably want to secure it because there's lots of really interesting, good stuff there that people might want to see. And I think if it's early days for you, definitely consider using the C2M2 V2 materials as a starting point for how you build your program. And start to think, well, what are my capability gaps and what's my plan to fill them? And definitely start that conversation with management. Start articulating the value and bring them on that journey. Then in the next 6 months, start to embed your cybersecurity approach across the life cycle of your new projects. And I think in 6 months, you can start building a formal uplift program you can audit your as-is state and then build a plan to get to your to-be state. So that's me, and I think I'm on time, which is really nice and surprising. I'm on Twitter at BLarge, and I have my GitHub where I throw up all my presentations. And yeah, really appreciate your time. Big shout out to Peter Jackson for, giving me a nudge to submit, and a big shout out to Rob for giving me some timely advice. Thank you.
Well done, Bruce. Well done. So that was fantastic. I was taking the piss out of you a little bit in the chat on like, I've never seen somebody so excited about frameworks and standards who then also knows them all and can back it up. Like that's impressive, man. So look, there's a lot of love in the Slack and some of you
awesome.
jump into, but I think the one kind of clarifying question was on the SAB, SA, SABSA domains. Sort of do they relate to the IEC 62443, or if you can expound upon that a little bit?
Yeah, definitely. Yeah. And it's actually a great question. So if you think back to SABSA and think about the different kind of like levels or layers, I like to think of 62443 as being the logical capabilities, right? So if you think about a zones and conduits model, like SABSA will talk about logical and physical, but physical is in a place, logical is a service. So the way I like to think of it is, say I run a SCADA electrical network. Logically, every transmission substation should be similar, right? I've kind of got my HMI layers, I've got my bays, I have some local control. That's a logical layer thing, right? And that's where zones and conduits make sense. Then if we step down into the physical layer, it will be for substation X, for network Y, there's this device. And that's where they interlock, right? So to me, you think conceptually of rather than, and this is definitely in the CMF as well, right? Like rather than thinking about every substation uniquely, group them. That's your conceptual layer. Then 62443 is for that site, this Purdue level, this subnet, these flows. And that's where the two tie together quite nice. And yeah, if you do, I highly recommend, if you look into SABSA, one of their kind of principles is we will align with other frameworks, right? And I think that's one of the key things is how do you align? How do you get terminology? Because it's difficult to have someone that can think at all levels. And I'm a design guy, right? So I'm a logical person, and I've been growing into conceptual. And yeah, we make jokes about fluffy clouds and wearing vests, but there's a point where you go, I can't think of everything all the time.
Yeah, no, and I definitely see people make the mistake of, I think I've invented a new thing, I'm going to make a new security framework or standard. And it's like, hold on, like just let's.
Yeah, I love that joke. It's like, I don't like the current ones. I'll build a new one.
Yeah, now there's 53. Yeah, but I think it's where I think I see people struggle with frameworks is largely not in that they disagree with the intent, but it's they struggle with the tangible. So I was really glad to see you pull out some examples of like, here's what we saw in the rail industry. Here's what we saw from a SCADA perspective. Here's how this can look. And yeah, go ahead.
Oh, I was just going to say too, like I've been fortunate. I've actually helped build a framework. It's super hard. I don't know what your environment looks like. Yeah. So I think the framework should guide you, but there's a point where me as someone that's helped build a framework, you know your network better than me, but just be consistent in the way you approach things. That's the key, right? So think of these as kind of like, guardrails. And it's quite interesting if you look at, say, TOGAF versus SABSA. TOGAF actually says use SABSA as a security framework. And if you look at TOGAF, it doesn't really have security. In my mind, TOGAF is when you're building things, think about security. Don't just, here's the security box, mission accomplished. Yeah. So yeah, no, it's really tough. But I think take what you want from them, but just try to apply it, consistently is the key.
No, perfect. All right, awesome. Bruce, fantastically done. Thank you for coming and sharing with us. Hope all is well on your side.